Hello everyone. I'm presenting R3-PCQA Ray-Reprojection-Reinforcement for No Reference 3D Point Cloud Quality Assessment. This research was conducted at the Visual Intelligence Lab at Hansung University. Our goal is a quality metric for 3D point clouds that follows how humans perceive 3D content. First, why does point cloud quality assessment matter? Point clouds are now essential for autonomous driving for AR and AR. But through compression and transmission, distortions are unavoidable and they degrade what that user actually sees. So we need a metric that judges quality the way a human would. A no reference perception aware metric. Human 3D perception has clear properties. The visual system has a sharp fovea and a coarse pupil, and it interprets a 3D object by integrating many viewpoints. As you can see, our prediction closely matches the human mean opinion score. Any good metric should respect these perceptual mechanisms. But existing state-of-the-art multimodal methods like MMPCQA and MFT-PCQA don't. They treat the 2D projection and the 3D point cloud as a separate modalities and combine them with night vision. Two problems follow. They process every region uniformly, and they lead the two modalities geometrically disconnected. So a distortion in 3D space is never linked to how it appears in 2D. Our solution explicitly models three mechanisms of the human visual system. 1. Viewpoint-dependent observation through geometric-aware reprojection. 2. Selective attention through a reinforcement learning subcloud selector. And 3. Multi-view integration through global view attention. Let me take these one at a time. Solution 1 addresses the absence of viewpoint-dependent perception. From the centers of an icosahedron, we render 20 views. For each view, we run k-means on the projected image, cast rays back into 3D, and find the point cloud each pixel actually hits. This gives us a precise, basically 2D to 3D correspondence, 9 aligned image and subcloud pairs per view. Solution 2 is the quality-salient subcloud selector. Humans don't weight every region equally. Local degradations dominate the quality judgment. Evaluating all 9 candidates is also wasteful, so we frame region selection as a contextual bandit. The context is the local visual patches, the action picks the single most salient subcloud, and the reward is prediction accuracy. Because the choice is discrete and non-differentiable, we train the policy with reinforce. To our knowledge, this is the first use of reinforcement learning in point cloud quality assessment. Solution 3 is the local view encoder. Here, ResNet captures fine texture distortions from the 2D image, and PointNet++ captures coarse geometric distortions from the selected subcloud. We fuse them into a coupled geometric texture representation for each view. A local regressor also predicts a per-view quality score, which stabilizes training and makes each view interpretable. Solution 4 is global view attention. Distortions are spread unevenly over a 3D surface, so plane averaging dilutes the worst artifacts. Instead, multi-attention aggregates the local view tokens and learns to assign higher weight to the most degraded views. Remarkably, this matches the wooden better theory. Overall quality is set by the worst view, and the model learns it with no explicit supervision. We train with a two-stage curriculum. A random policy at the start makes joint training unstable. So in the warm-up phase, the selector is off, and we train the feature encoders with random subclouds. Then in the joint phase, we switch the select on and optimize the policy and the whole network together, with an accuracy-based reward distributed across views by their attention weight. Now the results across all three benchmarks, SJTU-PCQA, WPC, and WPC 2.0. We also test cross-dataset generalization. Our oblations conform every component matters. Does the reinforcement learning actually work? Yes. The learned attention is also meaningful. Here, qualitative comparison against MMPCQA. Conclude, R3-PCQA is the first reinforcement learning-based point cloud quality metric. It builds an explicit physical 2D to 3D correspondence through ray casting, selectively attends to the regions that matter, and integrates view the way human perception does. The result is state-of-the-art accuracy with built-in explainability. Thank you for listening.